For our next problem here, we have x in the denominator, which means it kind of traps it down there. Also, that means there's some restrictions on that one. So before I even start, I like just noting what my restriction is. The restriction is a domain restriction. Domain means there's an x value that is no good. There's something that is no good here. There's an anomaly there. So what x value is no good? Well, it has the idea of a 0 on the denominator. So I think, when is the denominator equal to 0 here? Or x would make what? -5 to make 0 here. So I just like to note where x is not equal to 5. If I have a 5 here, I get a 0 on the bottom, and that's no good. So right away, I just want to make sure that I note that. Okay, so the strategy is very similar. We need to clear the denominator here. We're clearing fractions. This one is one of those where you almost have to clear fractions. So I want to multiply both sides by something that gets rid of all the fractions. Now, whenever you have x on the denominator, kind of the trick is you just multiply them as factors. So in this case, I have a 9 here, I have an x minus 5. It should make sense if I multiply both sides by 9 times x plus 5, x minus 5, the 9's will cancel, the x minus 5's will cancel. So that's our strategy. X plus 7 divided by 9 equals -3 over x minus 5. What am I going to multiply both sides by? This side and this side. What you do to one side, you have to do to the other. We're multiplying by 9x minus 5. 9x minus 5. We multiply that by both sides. Now what that does is it cancels the denominators. That's the whole point of it. That's the whole purpose. So in this case, on the left side, the 9's reduce out. On the right side, the x minus 5's reduce out. Remember, you can only cancel through terms. Like they have to be factors to multiply to cancel. I like to think of it like division and multiply go together. So that's why it has to be in like kind of this built form. And I'm not distributing it out because I want it like this so I can see what cancels. Okay, so now I have x minus 5 left over here, x plus 7 equals, I still have a -3 over here times the 9. Okay, so whenever you have binomials in parentheses, so we have multiple x's going on, we have numbers over here, our goal is to use the zero product property. The zero product property means we want one side to have 0, the other side has like the x squared or the factors, and then we can know that each factor has to be 0 for it to be equal. So we're kind of breaking it apart in that format or style. So basically the strategy is we multiply everything out and move everything over to one side, so one side has that 0 like I was talking about. Well, this is a binomial right here, so let's do some side work. I have an x minus 5 on one side, I have an x plus 7 on the other side. Now there's two or three ways, there's several ways you can go about this. This is a distribution. Everything in here has to multiply everything in here. So the x has to multiply to x, the x has to multiply to 7, -5 times the x, -5 times the 7. Maybe you remember FOIL. First, the first terms. That would be this. First terms. The outside terms, inside terms, and the last terms. That's your FOIL technique. So we like to use the generic rectangle that's easier to keep track of things and you're less likely to make mistakes. So x times x is x squared, x times 7 is 7x, x times -5 is -5x, -5 times -7 is -35. Okay, so these two combine and x squared plus 2x minus 35 is what we get from this binomial multiplication. On the right, that's just negative 27. So I'm going to write this all out. X squared plus 2x minus 35 equals negative 27. And I just want to show you, for those of you that like shortcuts, if you only have a 1 in front of the x's here, then there's a shortcut with these numbers, and it helps to kind of get that shortcut because sometimes we want to go the other way. Sometimes we want to factor this. So the shortcut is negative 5 plus 7, make this number positive 2, check. Negative 5 times 7, make this number negative 35. And then the rest of the structure has that format. So it does check out. And I got negative 27 there. So at this time, like we said, we want to move everything over to one side. We're using the zero product property. Plus 27, plus 27. And here's our problem, x squared plus 2x. That is negative 8 equals, our 0. That's the thing we need. So now the game is, and this is like what I was saying, you have to be able to kind of know some shortcuts here. This is a multiply two numbers. This is an add two numbers. Are there two numbers that multiply to be negative 8 and add to be 2? Are there two numbers that multiply to be negative 8 and add to be 2? So basically, I'm doing a diamond problem. Multiply to be 8, add to be negative 2. What two numbers? Well, whatever those two numbers are, the structure is, I know that it's parenthesis, parenthesis, equals 0. We have the x's in front. So it's very similar to that structure right there. So these numbers go in these spots. So did you think of what they are? 4 and 2. And be careful which one's the negative. In this case, the negative has to be larger. So a negative 4 and a positive 2. 2 minus 4 is negative 2. Negative 4 times 2 is, that should have been a negative 8. I forgot my negative sign. It's a negative 8. So that links together. All right, so it's a minus 4 and a plus 2. It doesn't matter which of these kind of come first or not. So what this is saying now is some factor times some other factor has to equal 0. That means one of these have to be 0. What would make this one 0? Some of you should be able to do this in your head, but here's the math side of it. I want to know when x minus 4 is equal to 0. So I add 4, x is equal to 4 there. So hopefully you knew that x was equal to 4 there. You could see that. If I put a 4 in here, that zeroes out. If I put a what in here, that makes 0. Hopefully you can see it, otherwise you can do the same structure, let it equal 0. Hopefully you can see negative 2. If I put negative 2 in here, negative 2 plus 2, that makes 0. That's my other x value. Now notice, it is not part of my domain restriction. We want to go back and just check. X is not equal to 5. We didn't get one of those down here. So we should be okay. And like before, you should check your work just to be sure. Plug your numbers back in to make sure everything's okay. But I'm pretty sure I did my math correct, so I'll leave it at that.